So I'll just remind you again that there's no homework due next Wednesday at midnight to give you time to study. And so, we've got our test next Thursday, so a week from today, right at this time, we'll sit down and take the test together. And it's on all of trigonometry, and you have, we've been working on trig a lot here, and now you have an entire week with nothing else pre-calc wise to do but study. There's lots of good information on Blackboard, and I encourage you to take advantage of that. Just as a quick reminder about the schedule, today you were supposed to watch a video about logarithms. I'm happy to answer questions about that. Monday is Patriots Day, so I didn't assign a video for Monday, but I am planning on just coming online at 11 o'clock to see if there are questions. Again, I don't know what else people are doing, but if you're anything like me, you're sitting at home without much to do, and I just I'll be available to help, basically. So if you have questions on Monday for review-wise for the test, we can do that. And then Tuesday, we'll do full-on review. So any questions you want answered, any topics you want to go over for the test, we can do that on Tuesday. We will also spend some of that period doing a little dry run of the test environment. So the way that the test is going to work is I'm going to split the class up into 3 different Google Meet groups because I've got several different screens at my house. And so I'm able to basically watch like a small number of people on each screen. And so I'd like to just sort of practice that test environment and then also have you submit a practice test, quote unquote. Not really anything math-wise, but I just want to see that you're able to scan something and follow instructions to submit it. So that, when it's actual test day, you've already done that and there won't be any hiccups. So basically, the next week is all about review, and I'm around outside of class times to talk as well. I've been meeting with people at night a little bit. Let me know if there are other times outside of class that you want to meet. Okay, so I'm happy to talk about any questions that you have. I do have a couple of questions that were sent to me that we can look at. Maybe I'll just start with at least one of them because it was from the homework that was due last night. So this is one of the, in my opinion, probably the hardest question in the solving trig equations homework. And it's got a secant of 4x, which makes it a little bit tricky. And so maybe let me just rewrite this down in case you can't see what it says. So this is secant of 4x minus 2 equals 0. So the way you solve this one is we need to start by doing a substitution because we don't really know how to solve things with secant. And then we've talked about sine, cosine, and tangent, right? And so we know that secant of 4x is going to be 1 over cosine of 4x. So you make that one substitution, and then it becomes a cosine problem, and it's a little bit easier to solve. Right, so you get something like that. And then you want to get the cosine by itself, right? Because the way that we solve all these problems is we want them to say like cosine equals a number or sine equals a number, and then we take it from there. And so we want to get cosine by itself. And so let's start by adding the 2 over to the other side. And then this is a 2 over 1. And so you can cross multiply to move forward here. So like the 1's multiply and the 2 and the cosine multiply, and you get 2 cosine equals 1. And then you just divide by 2 to get cosine by itself. And so that may have been the trickiest part of this problem, was sort of realizing that you don't really have much to do with secant. And so instead, one of the main reasons why we have these identities, and so we can take secant and instead write it as cosine to make it more manageable. Question so far? We're obviously not done yet. We don't have an answer, but that's the hardest part, I think. Thoughts? Okay, so let's keep going. So cosine, this are x values, right? So this is like an x value on the unit circle. So we're trying to think about where on the unit circle are the x values 1/2. And so that's either pi over 6 or pi over 3. I always have to take a second to think about that. That's going to be pi over 3, or the one that lines up with pi over 3 down here, which is 5 pi over 3. Right, this has the point 1/2 root 3 over 2. This has the point 1/2 minus root 3 over 2. But the point is, we wanted the x value to be 1/2, and so that's the two spots we're looking at. Now, the way this would work is with a normal problem is we write down like x equals pi over 3 plus 2 pi k, or 5 pi over 3 plus 2 pi k. But that would be if there was an x inside cosine, right? There's not an x inside cosine, there's a 4x. And so the way we talk about doing this is in the notes is instead of having x equals these things, you want the 4x to equal that. And so you carry out the 4 over here. Right? We want the answer for x, and so you want to get x by itself, and so you just divide everything by 4 to get x by itself. This is sort of the second tricky part about this problem. Again, this is, in my opinion, the hardest one in this homework set, which I think is why it's the last one. And anyway, so you divide by 4, and when you divide by 4, the 4 goes into the denominator there, and then it'll cancel with the 2. So you'll have pi over 3 times 4 plus 2 pi over k over 4, or 5 pi over 3 times 4 plus 2 pi k over 4. And, you know, we're trying to get it to look like the answer, right? It's telling us the answer looks something like this, and so we should simplify that down a little bit and see if we can get it to look like that. And so let's multiply 3 times 4 to get pi over 12. And then you can reduce the 2 and the 4 fraction to just get pi k over 2. And then this one's 5 pi over 12. And then again, the 2 and the 4 cancel, and so you get pi k over 2. And so now that looks like the answer, right? That looks like the answer with this being A, and then B, and this being B, sorry. Again, definitely the trickiest one in this homework set. I wouldn't expect to see one this complicated on a test because there's too many sort of moving parts to this. I try to keep it a little more straightforward on tests and things like that. But if you can understand how this one was solved, then I think you're in pretty good shape overall for the test. This involves substitutions. It involves solving an equation, knowing a lot about the unit circle. This is a pretty involved problem. Anyway, I'm happy to answer some questions about it, though. Can I clarify something about this one? Are there other questions about trig things? Trig homework or trig trig notes, trig review? Again, the test is a week from today. You should really be doing some review, I think, starting now if you haven't been doing it already. You know, I wasn't, to be perfectly honest, I didn't like always get A's on tests. In fact, I rarely got A's on tests, but even still, I would always personally start studying a week ahead. Just kind of looking stuff over, asking questions, doing practice problems. So anyway, if you're not doing that already, I think it's a good idea to start. But are there any other trig questions this morning? Just gonna pause for a second and see if anyone says anything.
Can we go straight to page 83 on the notes? I had 2 questions regarding that page.
Yep. Let me pull it up. Got my notes right here. Is this exponentials? Logs.
Common and natural logarithms.
This page?
Correct. Could you explain algebraically why e to the negative 1 power equals 1 over e?
Sure, yeah. So it's a negative exponent thing, right? So if we had like x to the minus 2, we learned in the very first section that you write 1 over to get rid of the negative, right? And so if you had e to the minus 1, that's a negative exponent. And so that becomes 1 over e, just to get rid of the negative. It's one of the exponent properties, an application of the exponent property, I mean. So the general property is a to the minus n equals 1 over a to the n. Do you know what property I'm talking about there from the first section?
Yeah, I just forgot, like, just a little.
That's okay. Yeah, that's fine.
Another question I had was regarding to the bottom of the page on problem number 4. It was log base x 25 equals 2. And when you deduct the equation, we have to square root 25. And you said on the video that we always have to do x equals plus or minus 5. When I did that by myself, I just went straight to x equals 5. So on the exam, if we don't add in an extra step of x plus or minus 5, you like points off? Are you looking for that step or no?
No, I'm not looking for that step. I mean, technically, no, I'm not. I wouldn't take points off for that. I mean, technically, you get a plus or minus, and then you look at the plus 1. But if you didn't like show that step, I'm not gonna take points off.
Okay. All right. Thank you.
So these are the notes that were supposed to be watched today. Does anyone else have questions about this specific set of notes, or if Cameron has other ones? I'm happy to keep talking about those notes. So this homework isn't due for like 2 more weeks, and so there's a little bit of a danger of forgetting about this stuff. Obviously, the videos are there, and we can go back over it again. But just keep in mind that this video is technically due today, but the homework's not due for a little bit. So if there aren't other questions about the notes, I had another homework question that I was going to go over. Someone had asked this specific question, and in particular, part D. And so this was from the homework due last night. There was only a couple exponential application problems. One of them was just asking you the first 2 parts here. So let me zoom in a little bit. You're given a function, and you're told it represents like the population of a community. So this is very similar to the application that are in the notes. So you have this formula that represents population. The first 2 problems are just asking you to plug numbers in there, right? So the first one wants you to plug a 0 in. So you just do that, right? And the second one asks you to plug a 10 in. So you do the same thing, but you plug in a 10. And so you can see like the population's going up as you increase the values there. And so the question that I had got was about part D, which says, if this % growth rate stays the same, when will the population reach 2,600 is the question. And so there's 2 ways to think about that one. One of them is a little outside of what we've learned so far, but one option would be to solve the equation equal to 2,600. So 2,600 equals 1150, 1.049 to the t. This is something that's covered a little bit later in the notes, though, and so if you're not ahead in the notes, you might not be okay with that option. The option that I was assuming people might take last night would be just to plug numbers in until it gets to 2,600. I mean, you already started plugging a couple numbers in, and you see it goes up. And so the option 2 would be just to plug in values until the population reaches 2,600. Again, that's sort of what I was anticipating people might do, although when I was looking over the solutions, it doesn't look like most people did that. I'm not really sure what people did or if they just got confused, but that's what I was thinking for that one. And I do have the work right here. Let me just, I'm trying to find it. I had it on my desk a second ago. But it turns out when you plug in 13, the population is approximately 2,600. And so I had just plugged in some t's until the population got close to 2,600. And it was just a couple more past this one, right? So you already plugged in 10 and got kind of close. And so it was just 3 more that you needed to try to plug in. Anyway, that's what I was thinking about that one. The solving the equation part is what's in the last section of the exponential notes. And so we'll see that after the test. Thoughts about that one? Or any other questions? Fairly quiet out there this morning, but I'm happy to stick around if people want to talk.
Could you use logs to solve D?
You could use logs to solve that. Yeah, so if you are a little bit ahead in the notes, here's how you actually solve this one. So the notes talk about getting the log by its, or the exponential by itself first. So you'd first start by dividing the 1150 over. So you'd have this. And then the notes talk about taking a log to bring down the power. And so I'm just going to use natural log. So I'm going to ln both sides. And what that lets you do is it lets you take the t and bring it down in front. And so I'm going to take the t and bring it down. And so we'll have ln of 2600 over 1150 equals t times ln of 1.049. And then you want to get t by itself, and so you just divide the ln over to the other side. And so this is another possible, this will tell you exactly when the population hits 2600. So that might, again, if people haven't gotten to that section yet, that's closer to the end of this section, but that's how you would do that by solving. Natural log, these are just numbers, just to be clear. Sometimes people get tripped up on that. When you see like ln of something, that's some number plugged into the ln function. And so that is some other number. So those are both just two numbers being divided by each other. And when you calculate that out, you'd get approximately 13 if you did it on a calculator.
Algebraically, can you do keep, change, flip process to simplify that fraction to a whole number? Or since it's ln, you have to just do in a calculator as is?
You'd have to do it in the calculator as is, yeah. So there's no flipping going on here. You'd have to do like ln of this fraction, and then you divide it by ln of this. It'd be two separate things that you would do, and then you divide the two.
I don't know if you set the denominator over 1 the way I was looking at it first. So.
Yeah, no, you don't.
Okay.
Just typing this in to make sure I did it right, but it looks correct. I was actually looking at the wrong problem when I did this one. I forgot that this one generates random problems. So in this problem, when you do this, this ends up being 17. I kind of combined my answer from two different problems. I'm sorry. Everyone has like different numbers in there, and I looked at two different people's problems when I was doing that one. Other questions? I won't hold you if there isn't anything else, but I do want to help. Let's also keep in mind, just in general, that tomorrow is the last day to drop any course, not just this course, but any course in your schedule. So if you're thinking about bailing on something, tomorrow is the last day to do that. You have until the end of the semester to switch to pass-fail, though, and so please do keep that in mind. If there aren't any other questions, I'll let you guys go. I'll post this video on these notes. Thank you very much for coming.